All right. So we have two sides. I want to be able to get a couple of different samples of the law of sines, law of cosines in here. So, solving a right triangle. We mentioned already you're finding A with the Pythagorean theorem. What's the equation? You got to show work. So, okay, so in this case it's A squared plus 7 squared. Whoop. Plus 7 squared equals 13 squared. Okay? So, what's 7 squared? 49. 13 squared? Good. 169. So you subtract and you get your A squared equal to 120. Alright? And then what do we do to solve from there? That's right. Square root. Square root. That's good. Okay, so we're going to square root both sides. So A equals, what do you guys get? Oh, I have it. Sorry, I have the screen frozen.
You're okay.
There we go. So it's 10.9. Okay, so 10.9.
So for like the tests and stuff, are we going to be rounding 1 decimal place or 3? Because certain has had us rounding to 3.
Whatever he did, whatever he had you do, whatever you. All right, so let's do one with law of sines, law of cosines here. Let's say we got triangle ABC again. And let's say I told you that this angle up here was 65 degrees. And I told you that, let's say I told you that this angle B was 40, no, let's make it something more realistic. So it look like maybe 70 degrees. And let's say I told you that side AC was 15 units long. Okay? Now, we don't see a right angle. We're not going to assume there's a right angle.
But we can find that angle very easily.
We can find the other angle very easily, okay? What's angle C going to be? 45, okay. 70 plus 65 is 135, okay. So 180, C is going to be 180 minus the 70 and the 65, which is 135. So you're right, that is 45 degrees, okay. Now that we know that, we've confirmed that this is not a right triangle. So how do we decide which rule to use?
Yeah, I don't know how to tell
It's like angle, side,
Okay, we had different patterns, right? We had angle, side, angle. We had side, side, side. We had side, angle, side. We had angle, angle, side. And side, side, angle. Okay. You had all these different patterns.
What do we have? Angle, side, angle?
We were given, I mean, now that we found it, we have angle, side, angle, or angle, angle, side, going on what we were given. So which law are we using here? We're in this group over here.
What's the difference?
Which law here?
Law of sine.
Yeah, we're going to use the law of sines, okay? We're going to use the law of sines, and I'll show you here the key to knowing which one that you need to use comes down to the layout of what you're given. So that's why it's important to see it. To use the law of sines, you have to have a pair across from each other. Yeah. That's a good question. Side, side, angle, and side, angle, side. Side, side, angle would be like I knew that this was 3, this was 8, and this was like 20 degrees. So I know two sides and then an angle here. Okay? Side, angle, side is I know this is this is 3 and this is 8, and say this angle here is 50 degrees. The angle is between the two sides that you know for side angle side. Okay? Yeah. So, when do we use the law of sines? We use the law of sines when you have one pair, a side and an angle, that are across from each other. Okay? So you'll notice here, in this case, I know, whoops, supposed to highlight. These are across from each other. Alright? 70 degrees is across from 15. When you see that, you can use the law of sines. Alright? If you think about it, the law of cosines, here's side angle side, okay? I have a 3, whoa, pencil. I have a 3, but I don't know the angle across from it. Okay, so what about the 50? I know 50 degrees, but I don't know the side across from that. Okay, I know this side is 8, but I don't know the angle across from that. So I cannot use the law of sines to solve this triangle, at least not right now. Okay, however, with this one over here, I have this 3, and I do know the angle across from that. So I could use the law of sines here to figure out what something else was in there. Okay?
I have a question.
Yeah.
So how do you set up the sine 70 and 15? How do you set that up?
Okay. Let's look at that. When we're looking at the law of sines, all right? Can someone tell us what the law of sines is? Remember the equation?
Sine A over A equals sine B over B, so on.
And sine C over C is the same. Good. And
So it should just be sine 70 over 15.
sine of 70 over 15. Very good. So that's going to be half of our equation. The next thing is just figuring out what we're able to find at this point. Okay? So that's where, since we know both of the other angles, we could find either of the two sides. Okay? This side here would be side A because it's across from angle A. We'd call this side here C because it's across from C. Alright? So we can actually find either one we want. Now, if I'm finding side A, okay, what would this side of the equation look like?
15 over, or 65 over A.
Very good. Sine of 65 over A. Okay? Does everyone understand how we set that up?
Yeah.
Okay? Again, I'm using 65 with the A because those are across from each other. Okay. Now, how do we solve that equation from there? Good, cross multiply. All right, so we'd have A times the sine of 70. Very good. Okay, so we're cross multiplying here.
Whoa.
Okay. Solving a proportion. Anytime you have a proportion, you can cross multiply like this. Okay, so you can plug that 15 times the sine of 65 into your calculator.
You can even use the other one that you just figured out.
Alright, so again, you cross multiply 15 times sine of 45 is C times sine of 70, and then you're dividing by sine of 70. and C is, what did we say again? 11.287. Okay? All right? Go ahead. Okay, so we have time for one more here, I think. What law do you think we should use? Since we haven't used it yet.
Laws of cosine.
Okay, so for law of cosine, we don't have a law of tangents, unfortunately. So law of cosine,
So are
what do we
gonna
have to know?
this on the test?
What's that?
We have to know like angle side, angle, angle side, angle, angle side.
You don't have to, here's the thing, don't try to just memorize the patterns. If you understand to use the law of sines, you gotta have a pair across from each other. That simplifies the whole thing. Because if you don't have a pair across from each other, you gotta use the law of cosines.
Okay.
All right, that's kind of the easiest way to remember it, rather than trying to memorize 7 different patterns or whatever. Okay, so if we have a triangle, and we were given, say, 12, 50 degrees, and 14. Okay, we don't have a pair across from each other, so we have to use the law of cosines, at least for the first step. Here's the nice thing though. If we use the law of cosines, that's going to tell us what this side over here is. It'll always tell you the side across from the angle you're using in your formula. Okay? In your formula, you have c squared equals a squared plus b squared
Well, you can do that.
minus 2ab cosine of angle C.
What?
That's the law of cosines. You learned that last week.
No, we didn't.
Or you may have learned it as a squared equals b squared plus c squared minus 2bc cosine of a.
I don't know what that 2BC is.
Can you label the
2 times b times c.
Oh my god.
Okay?
Can you label the
Cosines
triangle
stink.
like angle A and stuff like that?
Yeah, we could do that. Alright, so let's say that this is a, b,
Are
and
you
c.
like certain as if everyone like fails will be formative?
We'll see.
I like
Alright.
when you teach this.
I'm sure you guys won't fail. Alright, you guys
I
will
don't
do
know this.
fine. Come on.
No, I
All
like
right.
the fact that I can go and watch you do all of this later
Okay.
when I'm super confused.
Wait, I can.
Alright. Yeah, I'm going to upload this to YouTube. And if you go to the Sunday Post, I'll post a link to the video on YouTube.
Oh, that's sick.
So, alright. So here's the deal. The key is this. It's not the letters. It's the layout. Okay? Notice all 3 of the different sides are involved. A, B, and C. The key to the whole setup is that this angle over here has to be the angle that's across from the side that's by itself. They're across from each other in the equation even, so that's easy to remember. And here's the thing. You're either going to be solving for the angle or you're going to be solving for this side.
Wait, why is it C squared?
That's just the formula. That's how the formula works. Yeah. Okay. So in this case, C is going to be right here. Okay. So we have c squared equals 14 squared.
12 squared minus 2, 12 times 14 cosine 50.
Times cosine of 50 degrees. Good. Okay, so look at this. So this is all multiplication over here. 2 times 12 times 14 times the cosine of 50. One cool thing about this is it doesn't matter which one you call A and B. It's just the other 2 sides. Alright? So side C has to be across from the 50-degree angle, and that is what we're doing, what we're trying to find. Okay? The 14 and the 12 are the A and B. Okay? According to our triangle, technically 12 is B.
Is it always going to be cosine C?
It'll always be cosine of whatever angle's across from this side.
Of whatever angles across?
Yeah, across from here. So like, it's cosine of C in this case because we're trying to find side C.
Okay.
Okay? Now the cool thing about this is you just throw all this into your calculator, just the way it looks. There's not really any algebra yet. Okay.
But, can you just rewrite the formula?
You can.
Like, no, cause I don't understand, it's like C over A plus B minus 2ABC, like, I don't understand that.
C, this is C squared equals.
Yeah, and then, yeah, okay, sorry, and then A plus B minus 2ABC,
A times B times the cosine of angle C. That's what that's saying.
Oh, okay.
Okay, yeah, sorry. Yeah, it's 2 times side A times side B times the cosine of angle C.
When you get to the C squared equals the part, how do you do that?
So at that point, you're just figuring out what this equals on your calculator. Okay? So, did you already calculate that?
I got 2.57.
2.57. Okay. Did anyone else simplify that yet?
No.
11.137.
No,
Yeah.
sounds like it's probably right.
That's what I got.
Okay, that's what you got too, Taylor? Okay. Okay. That does sound more reasonable there. So, 11.137. Okay? And then we're just square rooting, right? We're going to square root that 11. Okay? Again, to undo that square, you're going to square root both sides. And we get 3 point what?
That was after it's square rooted.
Wait.
Oh, you got 11 after you square rooted. Oh, I'm sorry.
Yeah,
It was
I already had
124.02.
It was like 124.
Okay, hang on. So you got C is 11.372?
137.
137, sorry. Okay, and C squared equaled,
It was like 124.023.
okay. Okay, sorry. So yeah, so we've got this, you're just plugging right into your calculator. You have 196 plus 144 minus whatever that equals. Okay. All of that totaled up is 124. Square root that and you get 11.137. Okay. Now, real quick, what do we have now that we didn't have before?
Opposite.
We have something opposite, okay? So check it out. Now, we've got a pair across from each other. So what can we use now? The law of sines. If we can, we like to use the law of sines. It's a simpler formula, okay? It's simpler to manage with. So once you get that pair across from each other, now it doesn't matter if you find A or B, okay?
Angles, right?
You find an angle using the law of sines, and then you can just subtract to find your last angle, okay?
Or you get it,
All right.